All right. So thanks everyone for coming to the inaugural IPVM call. I'm just going to post the meeting notes here from the working group, so that if anybody wants to take notes during this, actually, could I get a volunteer, somebody to take some notes? Thanks. Great. So as I was saying before we hit record, I think most people are showing up hoping to see like what like progress or what's happening. But it's been about 3 weeks since Reykjavik, where we kicked all of this stuff off. There was in that meeting we were broken into, or people volunteered into working groups, et cetera. And I'm not sure if anything actually came out of those. So, and then it was also only the people that were in Iceland. So this is really meant as a way to see if, if any of those working groups have things to report back, some housekeeping, comms channels, things like that. And then also to invite other people into the project that didn't happen to be there in person. So quick recap of what we got up to in Reykjavik. So there was some small flurry of activity out there, and we all got together for a few hours and tried to figure out what are the main things that would need to get done to make a project like IPVM actually successful, right? So the main project goals were to agree on an invocation model, and then figure out some of the thornier problems, like how do you do verification? How do we do execution bounding? Do we include only WebAssembly, or do we also have something that includes Docker and other containers? And so out of that came, I believe, 6 working groups, people that were going to go off and explore things. So before we get into comms channels and what have you, I'd like to go around and just do a quick round of intros. And if you happen to be there and you happen to have anything to report back, that would be a good time to do so. So I'll start just as a template, I guess. So I'm Brooke. I volunteered myself into the invocation model group. Given the timing of Reykjavik and some other travel, I must admit that I haven't actually had a ton of time to make progress on that stuff, besides setting up some basic organization level stuff like the repo and discussions and channel and Discord, things like that. But I'm essentially trying to clear my plate and clear a few people at Vision so that we can work on this full time. This was on our roadmap from like October, November. And so with the interest, this has pushed that up a bit. So we've got to get a few things off people's plates. So working on the IPLI spec, mostly been digging into some of the invocation stuff at Compute Over Data working group, Fluence, and a few other projects, FVM, to see how they're doing it and how we can maybe harmonize those specs, so we can have just like one linked invocation spec, which would be helpful. And I'll hand it over to Adine.
Hi, I'm Adine. A lot of my time is spent doing things related to Kubo and being a maintainer, but also other projects in the space that end up springing up around that. I've been working a little bit on what it would look like to have a sort of an IPLD library that works with WebAssembly and has host bindings. There have been a few like community calls that have popped up to sort of explore a little bit about the WebAssembly, like how to use nicely and not just pass integers around universe. And so sort of interested in like how we can choose, one or two of those to like push our endeavors forward and make them a little easier to work with. Yeah, that's kind of that, and writing up things that came out of the event or what have been on my to-do list. Speaking of which, I guess I'll shout out the Aqua folks are having a meeting on Aqua VM and IPFS integration stuff tomorrow. In the Discord channel, there are links to it, and come by there and say hi.
Jonathan?
Hi, I'm Jonathan. I wasn't, to my infinite sadness, in Reykjavik, but really fascinated by this stuff and want to pick up. I attempted to attend remotely, which worked 60% of the time. So yeah, I've got a bit of catching up to do in terms of understanding exactly where everything is. But so I should probably be fairly quiet for the time being. Yeah, I'm a minion of Brooks, really.
Oleg.
Hi. So I wasn't expecting to give an intro, but I'm an associate software engineer at Red Hat, the Emerging Technologies Group. And we've been doing a lot of work with IPFS and seeing where it can lie in terms of decentralized storage. We've seen a few cool things from the outer core team regarding estuary and IPCR. And we've been looking at IPLD as well, but I saw that I actually saw that Discord channel made for the IPVM. And I think seeing where execution can go in a decentralized way would be really cool. I know that that's something that you guys have been working on for a while. So I just wanted to listen in the meeting and see where things are and see if there's anywhere that we can sort of help out with.
Awesome, thanks. Hannah?
Hey everyone, I'm Hannah. I work on, I mostly work on Filecoin things, but I'm have worked a lot in Go IPFS and IPL and also the Go IPLD libraries. I was in Reykjavik, but didn't attend the WebAssembly track because I had to fly out. And I felt and like I was at a meeting yesterday that made me feel like I'd missed a major sort of like component of the big picture. And so I want to understand more about like where this work is heading and how it fits into all the other layers, including the layers that I was close to, which were more around like IPLD itself and where it's headed. Yeah, I'm just mostly here to learn, maybe contribute at some point.
Melanie?
Hi, I'm Melanie. I work on the SCM team in Filecoin. And since Reykjavik, I successfully joined the community working group for WebAssembly. And the application is out for the WASI team. So I'm excited to take notes for us. Give an update whenever that happens, or whenever. So bi-weekly meetings. So yeah.
Amazing. That's yeah, I'm really glad somebody's going to those. That's awesome. Thanks. And James.
Hi, I'm James. Speaking of Brooks minions, I mostly do engineering management at Fission, so here to listen, learn, and make sure things run smoothly.
Right, awesome. So it sounds like, at least in this group, there's some interest in just hearing about sort of like overall direction, sort of short-term to medium-term plans and then some of the other activity going on around this. So I guess, yeah, there's in terms of communication channels, there's there's a Discord channel, and a GitHub repo organization, so IPVM-WG, where this video and notes will be posted after, and where if people have thoughts, ideas, want to start a thread, that's a good place for long-term discussion. We've had a lot of success with that in the UCAN and Web Data File System working groups. So figure we'll just keep trying that again and just run it as just a general open process. In terms of direction, where things are going, et cetera, so the big takeaways in terms of like overall system design from Reykjavik and like I guess hard constraints and things that people brought up. One is OCAP. So object capabilities. When you have a distributed system like this, obviously the and especially in an open trustless system, security is pretty important, and we can't really push that off until later. So we have to come up with a good story for that. There's a lot of work happening over at Agoric for these things, and it's been suggested several times that we probably take the design from Agoric's swing set project, or at least investigate that. I was also talking recently with the good folks over at Sprightly. They have a project called Sprightly Goblins, which is a OCAP distributed computing system that is just getting started. They have some code. It's mostly scheme based, but actually sounds pretty aligned with all this stuff. And there actually might be a fair bit of overlap. And in fact, they also have been poking around with IPLD and things like that as well. So it actually might be interesting to get them involved in this too. And then something we've been exploring at Fission a fair bit, especially if things are going to get pushed around on a sort of like a universal message, bus of some kind. I guess that I just literally described USB, but yeah, but distributed is data flow programming, and especially incremental computation might be an interesting direction for us to explore. So actually part of some database design work, we've been exploring distributed data log and thus also differential data flow, which seems like it has some really interesting touch points for this work as well. And I was hoping that because they had signed up, the author of IPFS fan would show up as well. There was some research done at Protocol Labs in 2020 or 2021 on doing function addressed network calls, which sounds like it's probably already explored a fair bit of this space. Aside from that, we figured it'd probably be good as a first quick win to get one spec where we can all agree this is a way to pass arguments to some well-known function on the network. And so with function addressing essentially the WASM module, some arguments, some extra config, and defining what that extra config should be, and then getting receipts from the computation, so that that it's been run, so that what the output was, so you can use that output in further computation. And that's something that the Fluence people have explored in some depth, is this taking a computation result out and then either re-queuing it or sending it to another process, things like that. So that's me ranting for a little bit here. I'd actually love to dig in, Dean, to hear more about the WASM IPLD project. So I've poked around with it a little bit, but like, what are the main things you've learned? What's the current status? Like, how what are the next things that it needs?
Yeah. So high level, and hopefully there will be more videos and stuff coming out about this stuff today or later this week. But the high level of like where I started here was there's lots of things we might want from WebAssembly and IPLD things, but like just as like the first step there is, can I make it so that some of the basic IPLD tools that I need to produce things like how UnixFS operates can be done without having to rewrite the code in every language for how UnixFS works, right? Like that's sort of a baseline. And the two tools that are required for that in the IPLD toolbox are codecs and ADLs. Codecs map bytes into the IPLD data model, is basically JSON bytes CIDs. And ADLs map data model to data model. And so those basically let you do transformations on multi-block data structures. Like say, this big tree over here, that's just a file. It's just a big file, don't worry about it. That's what ADLs let you do. And so the project was, so what's there right now is basically a way of working with codecs and ADLs that are written in WebAssembly from your host. Right now, I only have host bindings written in Go, but there is actually a defined ABI, and so you can move them elsewhere, which is something I found was a little difficult with some of the existing Rust WebAssembly tools. Is like, they're like, it all works. Here's your TypeScript bindings, but like there's no ABI defined, and so it doesn't work for anything that's not like the one language they wrote host bindings for. It's something I learned is like these ABIs will probably evolve over time. Like you're not going to get them right. It's probably not worth trying to get them right, but it is worth thinking about how we'll evolve them. The first step here was sort of to do a cop out and say, I'm not dynamically loading these over the network. I'm just sort of statically loading in the ones I need to. And then as we then figure out the next step of this, which is how do I deal with updating ABIs and versions for these things and dynamic loading? Okay, then we'll switch over to the dynamic loading part. So sort of the step at a time. I even have a demo of this, which is like integrated into Kubo to show how this works. And in a sense, the main things that are missing to make that mergeable are very little on the WebAssembly side and more on the IPLD side, which is that you need some way of signaling what ADLs to use. Codecs you can take care of because they live inside of the CID, but like what of these multi-block transformation functions, like do I use UnixFS? Do I use a BitTorrent one? Do I use something else? Like what do I do here? So those are, is it a filecoin ham? Like those are the things that you need to like figure out. There's a proposal for that. That's, I think needs work on in some eyes for how you would change this in things like URI schemes and other places. But aside from that, you're basically good to go from like you can play around, you can use this as a way of injecting new codecs and ADLs into the system. Like if you wanted to, probably we could merge things as they were if you just wanted to write codecs. Because codecs, we already have a place to plug them in. If you just wanted WebAssembly codecs in Kubo, I bet you we could like get that merged in and it wouldn't be too bad. Yeah, so that's sort of where that lives. And I think people have lots of thoughts around like, we'll call them naming and signaling, and how it is that you identify the code that you're going to run and how it is that you signal which code that you're going to run. The avenue I've been trying to push for is the like, make the broadest level hook you can get so that people can swap them out later as we learn and explore more avenues. Eric's written some stuff on the IPLD website that's sort of like here's all the different ways you could use signaling to sort of help illustrate, like, there's probably a lot of ways to do this. And here's all the issues that come with naming and dynamic loading, because some of these are easier problems and some of them are harder problems. So I guess the good news is, like, we have some stuff that's actually pretty close to usable or mergeable. And then it's given us some like good next steps to push on. And the hope is, like, I think if we start a little bit in this like static loading realm, or static can even include I hard coded in a CID or something, that we can then, as a group, like, learn more about how to build these ABIs, invocation layers and whatever, that we can swap over to something that's better there without being so concerned about like how the whole system will evolve. I guess maybe one more thing to sort of somewhat explicitly flag is, like, depending on how flexible you want to make the system, how, what sort of what that interface looks like between the host and the WebAssembly module. You can even do sort of like recursive types of operations that give you lots of power at the cost of some complexity and compute. And those types of things can include, like, you can have a signal that's like, hey, you should use this autocodec thing. It is a way of doing all of your signaling and what you want. And then you could signal that and then start using that going forward. But if another group doesn't want to use autocodec for whatever reason, then, like, they don't have to. And so that's kind of where I want the hooks to live, just because I think it may make it easier for us to move forward. But maybe not. Maybe we decide that there's actually like 1 or 2 hooks that we just want to hard code in and say, that's what we need. Yeah, I guess that's all I got for now. But if people have questions.
Hannah?
I'm just curious. I was just very briefly looking through the WASM IPLD code as you were talking. Like, how do you actually encode the IPLD data model in WebAssembly?
Yeah. So good question. So I'll tell you, there's sort of like a V1 and 1.5. So I started and I said, let's do codecs first. Codecs seem really easy. They're pure functions. They take bytes, spit out data model. I don't have to load in blocks. I don't have to call back to the host or do anything weird. If I have a block limit in place, my data is like generally fairly bounded. Nobody's writing codecs that are like 1,000 and the codec is like digits of pi, and then I have to compute them all. Right? People are doing more reasonable things. And so for that, I defined this thing. Basically, I defined a serialization format called WAC for basically serializing the data model. And so the idea was like, yeah. And this was basically, it both helped from like a programmatic perspective of not having to write lots of functions. You sort of just have one function, but also from like a performance perspective, you don't have to do multiple calls across the WebAssembly boundary. You sort of to create your node, right? You don't have to do all sort of the, create map, add entry to map, all across the boundary. You just sort of serialize once, ship it, other side will deal with it. So that was sort of version 1. The thing is that this won't work for ADLs because, well, it's not just that they're abstract, it's that their sizes could be enormous.
Yeah.
So even though I could download the whole thing, well, sure, but now I have to send like an exabyte of data across the boundary because I have a UniQS file that's an exabyte long. And so you start having to make partial functions. And so sort of where I could, I stole from the work that some people had already done in like the Go IPLD Prime library for how to do these. Like, what's a reasonable way to do partial functions on bytes? Maybe a reader interface that lets me read out a few bytes at a time with some offset, right? And then sort of make that one of the accesses to the host. Some of the other ones around like maps and lists, I sort of copied from what was there, but also along the way learned that maybe we need other types of interfaces. Like the interface for map in the Go libraries was only doing iterators. And so I ported over iterators, but iterators aren't great if you want to do things in parallel because the iterators move sequentially, right? And so those things will have to change over time. And so to some extent, what you have is like sort of easy things are easy, which is if it's just small data and it's a pure function, I can just encode all the data with the WebAssembly codec and it's fine. And once you start getting into how do I deal with big object, now you have to deal with how you want to, what partial views you want into the big object so that your libraries and the host can work with them effectively. I think we're still sort of, I think we still need to do a little bit of like exploration work there. And probably we would see that if we started doing things like, I saw you started some work on like, sort of, parallel selector traversals and that kind of stuff. Seeing how it is that we would use the ADLs to say properly express the map parts of UnixFS traversals. Because we already have bytes, which is this sort of reader seeker model, but how do we want to do it for really big maps? And I think that like, sort of as we push at the obvious really big things are like maps and lists and bytes and maybe strings. And so I think as we have examples that push at those, we'll sort of see what we think, what the interfaces need to be. Which is why I think the ABIs will continue to be in development for a little while as we poke at the use cases and like learn what it is that an application actually needs out of this in order to make it efficient and go fast.
There's also a bunch of like interesting little things around the data, like even lower level things with the data model where like ambiguities in the data model, like what is an integer and like what are its bounds and how does it behave? Like if you like whatever WebAssembly decides will probably have a big weight in like what other people do. So it's an interesting moment to push on that front. Yeah, it's interesting. Yeah,
I mean, that's why for some of these things, what I kicked was for WebAssembly for integers, I was like, or for the codec for integer for WAC and doing the data model encoding for integers, I was like, just use a varant.
Right. I saw that.
The application layer will decide how many bits is too many bits for it, right? So that Go can say it's 64 bits and Rust can say it's 128 bits and JavaScript can say it's 56 bits and like, that's all fine. I was having a conversation, I have to post the updates with Volker about what to do with floats. I think floats is maybe a little more like people are okay just saying it's a 64-bit IEEE thing and calling it a day because floats can get really complicated. So probably for that one, maybe we just take the easy route until it is deemed necessary and someone says, no, I really, really need big floats. And then we'll figure it out.
Or big ints. I mean,
well,
also like
varants are big ints.
But there are two different types in Go. Like, how do you choose what to decode into? There's like, I mean, I would say like when in doubt, there's a bytes type that you can decode with an ADL into whatever you so choose.
I think floats you have more latitude because people don't always expect that to be deterministic anyway. It's like the ball is very low, the bar is very low.
But that might be a problem, especially with content address data, right? Where you expect everything to be deterministic, but WebAssembly, I think there's like two sources of non-determinism today, and one of them is floats depend on the host.
I mean,
Yeah,
not really.
I think the IPLD website, I'm almost certain says like floats, they exist. Use with caution, because every language and everything has its own way of doing floats, some of which is outside the scope of like what IPLD can mandate.
There's not really a reason to. No, sorry. So there's actually like a simpler path forward than trying to like define an API. We could just steal one from C and run with it for now. And that may be something that people just want to do anyway outside of our own spec. But yeah, that's just an option.
By steal one from C, you mean like basically have your pointers be to C objects and then do that?
Yeah, just steal the C API and then have that as the definition.
And then, yeah,
So
that's what I currently have is everything is integers, and then there's C objects that you're passing around.
okay.
I think with ADLs, there's a lot of prior art in sort of the XML processing kind of world to both inform and, you know, act as a counterexample, right? I think one of the informative things is that no one stack is good enough for everybody, right? And that there are people who are very wet, and there are solutions that are, you know, very optimized by a sort of a push stack, and you can compose your transformers that way. And there are, you know, also solutions which, you know, work very well with a pull type stack where, you know, you are able to make requests to select parts of the base data model, and that actually you probably need ultimately to specify both, because what really doesn't work is when you have kind of, you know, you try and join a pipeline that is working on a sort of a pull type metaphor with one that's working on a push, and that sort of impedance mismatch creates all kinds of requirements for buffering that suddenly make it extremely stupid. So yeah, I mean, I think there is significant prior art in terms of you know, the kinds of problems that are going to crop up, you know, in that XML world. And I know XML is kind of, you know, 2 technologies ago, but it's still the same problem from a sort of, you know, high level view as the ADL problem, and that those basic kind of differing approaches are probably still valid.
I have two questions in my buffer. So first one, probably just a quick thing. Can you tell me a little bit more about the hooks you were talking about?
Yeah, so you need so I guess you mean like the signaling hooks, almost certainly, right? Okay. Yeah, so right now there are everywhere that someone has used a CID to like identify data, there is implicitly some like application requirement of like, but I mean the data, like do the data like this. As examples in like if I look at, you know, like the Kubo command line things. So if I use like block get, it says get this data as a single block. And if I say pin, it tries to walk the graph and pin and get all of the blocks that are touched by the graph, right? And all I say is they just plop in a CID and that's it. But there's an implicit behavior associated with it. Similarly, when you type in like, when, you know, IPFS:// into like Brave, there's an assumption that's basically check if the data is UnixFS. If it's not, see if it's a data model thing, and then path through it. and then make sure that whatever you land on at the end is a UnixFS node, and if it's a file, render the bytes, and if it's a directory, render some special HTML page. And like, that's all of that logic I just described is like encompassed in IPFS://. Like that's where that signal lives that tells you what to do. There are other places people might want to put signals, right? So sometimes people want to put signals inside of the data, right? Which is a little bit like the autocodec proposal, which is like, we'll have a signal at the top that says, hey, I'm using autocodec. And then for the rest of the graph, I have this in-tree signal that I can check to figure out what it is to load next and how it is to operate with the data. You could put the signals in like your descriptor. So for example, for URIs, Mauve showed like some example like URIs for an IPLD URI scheme that sort of look like I do pathing, but anywhere in the path where I want to explicitly use like a multi-block data structure or something, I say, hey, traverse this thing as if it was a HAMT, and then keep going forward, or assume that this thing is a BitTorrent object or UnixFS object, and that's another place you could put the signal. Let's see. I always forget there's like a whole bunch of them, so I always forget where they are. I mean, generally it's in band, out of band. Yeah, I guess one is you could skip the whole thing. You could just say, when I write code, I just know what it is. All right, that's like sort of like block. I guess it's a little bit like block get, right? I know what it means here. You could use schemas, right? You could use schemas to define, what your data is going to look like and where all the signals live. I think Stephen has had some interesting ones as well. He gave a talk in Iceland about. I think this works as both in and out of tree signaling, but basically allowing data to define. I think this was for in-tree signaling, allowing data to define like, here are sort of the interfaces I expose. You can look at me this way, or you can look at me that way, and then allow the systems to sort of compose themselves as they figure out, oh, I need one of these to plus one of these to get over here. But as in a sense, sort of the trick is to like have any of these pluggable somewhere. So like the first version of the demo I did was I used selectors as the signal, because selectors have one of the clauses you can use is interpret as, which is just a signal that says, here's how I interpret the data. The next one I used was with this IPLD URI scheme. It doesn't matter as long as there exists a signal somewhere. And again, if you're doing this at the application, like this is mostly when you want to allow users to choose different, to operate with different signals. Sometimes if your application is really locked down, if I want to make a BitTorrent client that uses BitSwap to pull data, I don't have to know what UnixFS is. I can just hard code and say assume BitTorrent ADL everywhere I need to, and that's fine. It's just that as you start hitting things, whether it's like URI schemes or other API interfaces that face users, you need to have like a signal somewhere.
I really agree a lot about signals being a sort of a fundamental kind of like point of consideration. I think one of the risks that I'm kind of seeing in the discussion in like the IPFS universe is kind of a confusion between, I guess, what I would call a declarative signal and an imperative signal, right? That like there are lots of places where the publisher of the data wants to declare this is what this is, right? This is an HAMT. This is how it should be interpreted. And then there are also cases where we have the consumer of that going, what I want is this, which is kind of an imperative signal. And I'm not sure that they always need to sit in the same place, or that there shouldn't be a sort of distinction between the two. That there are so many use cases for signals. And it's almost like we've kind of got to a point where everybody's just going, yeah, signals. And it worries me a little bit.
I would just point out as y'all move into this, that signal, how to signal is probably one of the underdeveloped, like under agreed upon ways, aspects of IPLD. And like for example, that explore, interpret as thing, which is meant to like send things across the wire. Currently it's explore, interpret as like known ADL, where known ADL is string, and either the publisher knows what it is and knows how to run it, or they don't. So it's like not a thing that is well developed, but it works for for Unix FS. But yeah, sorry. Yeah, go ahead.
I mean, I guess we're getting off of pure like IPVM stuff, but still interesting discussion. So it's, happy to take us in these directions. I wonder if these are at different layers, right? Where you could have this inline version, and then if you want to specify that, and that's the ground bottom truth that the interpreter will run, right? And then if you decide that you want to have a different ADL or a different WASM blob run over it, you can specify that in a URL or something else, and your clients can do that switch for you or place a node in front of it or anything like that. And you can just harmonize both of them with the more powerful, and I mean powerful in like a VM sense, tool, and then let every client implement whatever label signaling mechanism they want on top of that, but that you can always get down into this mechanical layer. Just a thought. So
yeah, and again, so what I was saying is like you end up having the signal implicitly anyway, right? So like if I say I want all my signals to be in the tree, right, in the sense the declarative way, like inside of the structure of the tree, it says how I want everything to be interpreted. That's fine, but you end up with an implicit signal somewhere else that says, hey, by the way, this is the scheme I'm using to do the interpreting, right? And so if it turns out that there's like, a way or two of doing that we want to like stamp as the way, sure. If we want to have systems where people like explicitly pass the, hey, I'm using this in-band signaling business, go use that. The rest of the data is in there, I swear, don't worry about it. We can do that too. I think it's just a matter of like, what's gonna be the sort of, I guess, what's gonna be the easiest thing to move around. And again, to some extent, the reason why this stuff, the WASM IPLD stuff exists as a separate repo from all the Kubo things is like, your application might have a different approach to do signaling, and it doesn't need, so like, right, if Kubo is interested in figuring out how we deal with URI schemes, and we're still figuring that out, but you just want to get a move on, you can just grab the library and you know what your signals are, and that's fine.
Well, I mean, I'm not quite sure you're right, or that the prevailing wisdom is right, in the sense that, you can go with essentially duck typing, right? Your data is your data, and if it fits the hole you're trying to squeeze it into, that's fine, right? But the way we have currently got schemas is kind of as something that can be injected at the top only, right? So essentially that is a static typing layer, right? You can say, here's my application, here's a schema for it. And because the only place you can really put that, inject that or signal that is at the top, that almost implicitly gives you a static typing design. Whereas, of course, what you really want is a bit of both. You want JavaScript typing, right? Or TypeScript typing, right? You can use types where you need them and not use them where you don't, you want that ambiguity. And I suspect that to get that third kind of characteristic, you need a way of embedding signals that's a little bit more defined than we currently have. And so I think that's where we're going to wind up going. It is, yeah, we have these two extremes, and then we need something in the middle that lets us, inject those type signals in a relatively standardized way, so that we have that good compromise.
Yeah, like arguably, this is why IPLD is useful and successful. Is it's the one standard way to push stuff over the network, right? And we don't have to worry about like, is it JSON? Is it something? It's like, no, it's just like it's bytes, and then on the other side, okay, I have bytes and links, and I can pull that out, and then I can bootstrap up some richer data, right?
Yeah, I guess if folks are interested in this, there's some discussion that's ongoing now about sort of a proposal for like version 2 CID, which sort of chucks metadata on the end. And there's different ways and reasons why you may or may not do that. That may be a place people have thoughts or want to engage, because to some extent, I guess my thoughts on the proposal is it's trying to find another way to like put signaling in at sort of a particular point in the a particular point in the stack. Maybe it's the right point, maybe it's not the right point, maybe it is a point, right? And there are other ones. Yeah, there's some conversation there that if people are interested in this conversation, they may be interested in that one as well. And that's in the IPFS specs repo. I'll link.
There is sorry, I have two thoughts. One is a meta point about like interesting thing that may come up in the course of like building this IPVM is that, and Signal is an example of this, which is like things that are not done in IPLD, things that are not well understood, things that are not well agreed upon. So that's an interesting thing to think about, like where will this group get support in not getting pulled, like getting the whole project drawn into solving IPLD's issues. That's an the other thing but my question is like, so I just was flipping through all of your slides of your presentation, Brooklyn, like how, maybe you could, there is a bootstrapping section, but like, how are we getting this off the ground, right? Like, I mean, like there's like, I would love to imagine a world where one day we're, just sending around blobs of computing, addresses and, decoding all our codecs via, via remote WASM code. But like, but I'm curious, like, what's the path to like building a thing that does a thing? Yeah.
So you mean flipping through the IPVM slides, not the autocratic slides, correct?
Yeah, this is the the IPVM slide that you put up for.
Right. Yeah. So at the end of the day, I think the only path forward is rough consensus and running code, the IETF style, right?
Yeah.
Somebody has to write, like, yeah, we can get together and chat about like, here's the interfaces and here's how it works. But really people doing implementations and getting their hands dirty and figuring out like, well, these were the problems, here's what I learned, is of a higher value than, well, what about X, what about Y?
Yeah.
And keeping it like, and it's a relatively like messy, in scare quotes, like, dirty process, because you don't get this beautiful spec and then you go off and implement it, right?
Of course, yeah.
Yeah, but that's kind of at least how I see it moving forward. And so like at least Vision is going to be doing an implementation of this, and with the understanding that the interfaces and the exact implementation underneath that is going to change, but we're going to start getting experience with it, right? In the same way that polywrap influence and FVM folks are getting experience with things like that are highly related, but now we're trying to harmonize how all these different systems work, right? And for currently, the scope is like an extremely wide set of use cases, right? It's like,
Yeah.
at least for Fission's use case, everything has to be able to run completely locally and offline.
Yeah.
But then also be able to take this off into separate processes. And we want, a global memoization table and like a bunch of these other things. I see Mike.
What are you all using it for? Like, what's the end thing able to do?
Everything that in our specific use case, anything that AWS Lambda can do, but we're looking to have it as a protocol instead of as, sometimes I describe it as like the HTTP of AWS Lambda, right? It's an open protocol that anybody can use, that anybody can accept jobs off of, that you can add payments to or not, that you can run totally locally or not. But then there's other people have other use cases, right? So the Bacalhau and compute over data folks want to do extremely high parallel, like embarrassingly parallel workloads, primarily aimed at data science machine learning, right? Which is a very different use case. And so some of the discussions that we had in Reykjavik included things like, well, what if we could have a single, let me take one step back. If you look at blockchains not as a separate system entirely, but as a new primitive that works well with cloud computing and local first computing and all these other things, then there's this gradient between I ran this stuff entirely myself versus this is going to a trusted provider or untrusted provider, or I need global distributed consensus on it, and I'm willing to pay the time that's going to take, right? And so, given that this is all at base bottom computes, would it be possible for us to have one spec that says, yep, this is going to need consensus on it, or I need this with a fan out of 10 million machines or whatever it is. But that's also pretty general, right? So, yeah. Sorry, does that answer the?
Yeah. And like, what's your like target timescale to ship a thing?
Yeah. I mean, as soon as possible, and I want to start getting started with like, in the category of like dumb experiments, like pretty soon here. I'm just trying to free up resources internally, because we had this set for a couple months from now. But my hope is that by the end of the year, we can have a really solid invocation spec and at least one implementation that people can play with. And so that's like, it feels like a very small wedge, but that would immediately be a huge win, because now you have one mechanism for having this run in a bunch of different systems, and we can all agree on here's how the data is linked together, here's how I pass arguments to it, all of those things. And then we can start to dig into what's the level of determinism that we need. What if I need verification, and all of those problems, which are much broader. The topics that came out of Reykjavik, just to run down the 6 or so things that came out of that conversation, that it was like an all morning thing, was IPLD calling convention, a WASM IDL, execution bounding, gas was what came out of that, invocation loading, hypervisor, and IPLD linking, right? Because we also want to be able to IPLD link WASM modules together. And potentially even have some of those. There was some discussion about if that should be always totally concrete, or if you should be able to load in like IPNS or something to do a mutable pointer in there. So that's kind of like the initial scope. And then people broke into or signed themselves up. So there's like a couple people for each of these. We said like, don't sign up for all of them, right? Like one or maybe two, and then go off, self-organize it and come back. So like my interest is in the invocation portion, at least getting started here. But in theory, people could start on any of these things. Does that make sense, right, roughly as a roadmap? Would you look at it differently? Would you do it in a slightly different way?
mean, I would say the part that makes 100% sense is build something that works for your particular use case. Like, and that sounds like what you guys are doing, and then like, yeah, specs and things will emerge out of it afterwards. And you know, and then when we try to, I don't know, integrate it into the standard, you know, distribution of Kubo, that'll push it more into spec territory in a future thing. I mean, yeah, I can't claim to understand all the problem space well enough to fully understand what like how much work it is and like what you're going to be able to get done by the end of the year. But look, when we say when we talk about, we keep saying IPLD, linking via IPLD, like, are we talking about IPLD like SIDS and bytes, or IPLD SIDS in a data model deserialized from CBOR or protobuf or something? Like, what, I'm curious, like, what is that? What that's, I think that's part of one thing where I'm confused when we keep saying IPLD-VM, what that means.
Yeah, so the current working hypothesis basically is that there's two layers, right? First is that we need some way of composing WASM modules, right? And that's both, at least to get started, that's just directly to say, you know, the output of this one's going to go into the input of that one, and we'll build up some kind of a tree or some kind of a DAG, right? And so it's a container formats that then has WASM hanging off of it, basically. And then separately is the top level invocation spec. So there's a little bit of this already starting to happen actually in over at DAG House for doing authorized invocation without WASM, right? And so
Oh, she crashed.
Oh.
Well, hopefully back soon.
In the meantime, I want to make a quick funny note. So last week, I came across the exact issue that this would solve in the FVM when we're trying to talk about constrained runtimes. So just a funny little haha. I want this, but yeah.
I don't know when Brooklyn's gonna be back, but I just realized I have a meeting I gotta go to. So sorry. Please send her my regards and apologize profusely.
She's back.
Yeah, Brooklyn, I have to go, so I'm not going to catch any further of your explanation. But thank you. It was really, really interesting to learn more about this.
thanks. Yeah. And yeah, we are at the top of the hour. Sorry, Zoom crashed on me. So yeah. Yeah, so actually we're slightly over time. So I guess if anyone has any last couple things that they want to talk about, like in extreme brief, this is the time. Otherwise, we have this set up on a monthly recurring schedule. There's the org if you want to start discussions there. In the GitHub discussions, that's great. There's also the Discord channel. We're also going to set up a because people have asked a Discord to Slack bridge at some stage, just to make it easier for people to engage with stuff where they are. So, and any final points before we wrap this up?
Yes. Do we? So I'm going to be taking notes during the community group meetings. Where should those be? I'm guessing one of the repos, but I believe there isn't like a designated spot for it.
So I mean, I'm open to other options too, but we've had success in some of the other working groups with just putting them in the GitHub discussions on the specs repo. So IPVM-WG/spec. And then in the discussions, we could even create a category for like meeting notes or something. Thanks, James.
Is that accessible enough. Because that's just assuming you have GitHub to interface with it.
Uh,
Yeah.
As opposed to,
As opposed to like having like markdown documents in the actual repo. Or no, sorry. This is I'm talking about notes coming or notes that I take during the community meetings during at the W3C.
oh,
Not
I
this one's.
see.
Yeah.
Oh, I got it. Yeah, I mean, either GitHub discussions are also marked down. But if you want to create a directory and we put them in, .md files, I mean, it doesn't make a huge difference to me. Anybody else have a stronger opinion?
No, pretty sure all of the GitHub things are bad for asking questions. So whether you use a markdown file or discussions, they will all be equivalent.
Yeah. Okay, that works. I'll probably just make a directory.
I guess if you make a markdown and you do it as a PR, then people can leave comments on the PR and ask questions there, which I guess is a way to get some way of being able to ask questions on the large notes.
Oh, and that's, yeah, that works for both. Although it doesn't render, unfortunately, but yeah, that's fine.
All right, awesome. Well, thanks everyone for showing up, and I'll see you all in September.
Bye.